Hello, my name is Andrew Trask. I'm a PhD student at the University of Oxford and the leader of the OpenMined community who is putting on this conference. And in this session, we're going to tackle a very challenging question, which is, given all of the effort that's going on in the privacy community, whether it's the algorithms that are being invented or the software packages that are being engineered, the laws that are being passed, institutions and corporations being set up, all for the sake of privacy, what does that actually mean, right? What is our overall overarching end goal that we're trying to get to as a community, and how is it that we should get there, right? What is our roadmap towards getting to that destination? And it's funny. There's a lot of effort happening already for me to then ask the question, where are we actually trying to go? But I hope that you'll bear with me through this conversation as I and two colleagues of mine, Nick Rose and Ronnie Falcon, attempt to sort of synthesize all these different efforts into kind of a combined philosophy and combined roadmap, and give us a point of reference for how we want to ultimately accomplish privacy, whatever that means. So the first half of my talk is going to be first talking about what is the actual destination, right? And the second one is going to be talking about how should we get there, right? And none of this you necessarily have to take as gospel. This is going to be an outline of what OpenMind's roadmap is, but it's not prescriptive to OpenMind, to the extent that we as a community are just trying to choose what problems we think are most worth solving. So to that extent, let's jump in, and then after my talk, giving kind of this sort of overall long-term goal, Ronnie and Nick are going to carve that into three main groups, or three main projects, or umbrellas of projects, really, under which privacy efforts and technology and initiatives sit. So let's begin. Part one being about what is it that we're going to try to accomplish? What is the overall destination of privacy technology? This starts with the last talk that you heard just before this one, with Dr. Helen Nissenbaum, who put forward this philosophy of privacy as contextual integrity. And when I first heard this philosophy of hers, it just made something click in my head for the very first time. And what that was is that privacy is not about just hiding information. It's not about locking it away. It's not about end-to-end encryption. I mean, it's related, obviously, but it's not about just trying to lock down data as much as possible. Because the big problem with the existing narrative, the existing destination that a lot of people put forward for privacy technology, of sort of just locking down and hiding information, is it creates a huge number of false dilemmas, which can be grouped into basically one big narrative, which is privacy versus everything we ever wanted to do with information, right? Maybe we wanted to innovate, right, and do science. Maybe we wanted to, protect our country, national security, right? Pick literally any kind of useful thing to do with information, and someone has said privacy is going to slow it down or is going to be against it. And when I learned about Helen Nissenbaum's philosophy, it became definite that is a false choice, 100%. And that, to me, is the beginning of answering the question, what is it that we are actually trying to accomplish with privacy technology? Because what Dr. Nissenbaum defined it as is not about hiding information. It's actually about flowing information. It's actually about creating very specific information flows amongst specific parties in society to create the outcomes that you want in life, right? It's, put another way, privacy is not about privacy. Like privacy is a means to other values. It's a means to accomplish liberty. It's a means to accomplish national security. It's a means to accomplish accountability or innovation or whatever it is that you want your information flow to do for you, right? And the challenge of privacy is that it's really, really hard, traditionally, to get information to just flow from one person to another, or one aspect of society to another. And I know we're all talking really abstractly. We'll get more specific in a second, but just to start off, the starting point is privacy is not about hiding information. It's about flowing information very specifically. It's about saying this person should know this kind of information and shouldn't know this other kind of information, right? Okay, so we have this new definition of privacy, new definition of what we're trying to accomplish, right? And those of you who are experts will notice this also subsumes things like differential privacy, which is like one formalized definition of privacy, which is just in the context of aggregation. And you should note that it also subsumes end-to-end encryption, which is one way of sending a piece of information just from one person to another person, right? So all these different pieces, these different cogs fit inside this philosophy of privacy as contextual integrity, right? They're all means by which we can cause information to take a very specific route, right? And I'll take a quick pit stop at these examples just so you can see how they plug in. So differential privacy is a definition that's looking at privacy in the context of statistical aggregation. So we want to study some data set for some trend, right? And we're trying to have a one piece of information come up to a scientist, which is, some trend, what causes cancer, for example, while preventing a different kind of information from coming with it, which is individual, patient records or something like this, right? So, we want a scientist to be able to learn what causes cancer without the scientist also learning, Bob Jones has cancer, right? Again, that's not all of privacy, right? That's just a big part, right? Differential privacy is a really big part, but it's not the whole thing, right? End-to-end encryption is not private. Like, our goal should not be to end-to-end encrypt the whole world, right? That would cause all sorts of really bad things to happen, right? Because just end-to-end encrypting is it's such a hard and far, we would not fully grasp the social norms, all the good things we want to do with information, right? Despite the fact that it would prevent lots of potential misuse, right? But each of these tools in the right context are really, really important. They map into this more broad definition that privacy is about selecting desirable information flows. Okay, so now let's go on to the next sort of slightly harder section of this question, and this is this next piece, right? So if chapter 1 is privacy is about information flow, chapter 2 is about asking the question, what information flows do we want to have happen? And that is such an enormously broad question, enormously broad, and because information touches every aspect of life. It touches everything from our personal lives at home to industrial commercial applications, R&D building jet engines, to understanding some of society's biggest problems, like how immigration and global warming and new sources of power and energy, and like it touches everything, right? So how are we to say that we can build systems that make good flows of information? I mean, this is a really it's enormously broad, and this is one of the areas where I think when people try to talk about privacy, so first we have this better definition, right? Privacy is information flows, but then it's like, oh my gosh, how in the world are we possibly going to tackle all information flows, right? And for me, you just gotta zoom out to the things that you most want to accomplish, right? So again, just to roll where we are. Chapter 1 was privacy is set of information flows, and now we're trying to answer the question, what information flows matter? The first thing to do is acknowledge it's an enormously broad question. There's no way we can actually touch all of it, but we can find some really, really big patterns that privacy technology can be applied against, and this is really where the creativity of the community and of everyone is really going to play an important part, right? Okay, so, but let's take a stab at this. Let's make an attempt. In my world, we can group all of human problems, right, into two big groups. One group is prosperity, meaning we understand nature better, thus we can prosper more, right? We understand nature better, so we can extract more food from the ground, or we can create more efficient energy, right? Or we can have more efficient transportation, or we can, it's all about being able to more efficiently extract resources or collect the resources that nature has given to us, so that we live, better, healthier, longer, happier lives, right? And when we think about all the things that are in this area, it's broadly speaking science and R&D, right? Cool. So the other huge topic or group topic is, given that nature, the earth, gives us a certain amount of resources that we can capture as a society, how should we distribute them, right? And this is the realm of democracy and capitalism, predominantly, to the extent that democracy says we should distribute them in accordance with how people vote, right? So sort of one person, one vote. And then capitalism says we should distribute it according to sort of money and how much value you can create, right, with those resources. So it's sort of like $1, one vote, right? And these are two big systems that we have to try to figure out how we want resources to spread. Okay, so now, because it is a little bit abstract at the moment, I want to continue to checkpoint where we are, right? So part one was, what is privacy? Privacy is all about facilitating specific kinds of information flow. Okay. Chapter 2 is, okay, given that we know that we want to create certain kinds of information flow, what information flow should we care about, right? And so in trying to tackle this enormously big problem, we're going to start by grouping all of society's problems into two big groups. One being, how can we facilitate innovation happening as fast as possible, so we can have a prosperous life and we understand nature and we can have more, better everything, basically better science. And the other one is, how should we distribute resources, which is a function of capitalism and democracy predominantly, right? And so the big theme here that you should be seeing when we start to get to these two big groups is that it's all about institutions, right? We have very large institutions that govern these sort of three big activities, right? Where one activity is sort of the activity of innovating, right? And of learning about the world at a deeper level. And then the other two are about regulating how those resources that we receive from nature, right? When we start using these systems, are distributed amongst the people. And so now we ask the question, what does this mean for information flow, right? The whole point of this kind of chapter 2 segment is to say, what kinds of information flow should we be trying to chase and trying to facilitate as privacy experts, right? And so in the realm of science, what's actually going to be covered in detail in a moment by Nick Rose, it's really about facilitating sort of the positive uses of innovation, of data for innovation, while mitigating the negative uses of data for innovation, right? And truth be told, that's all about positive utility without the negative utility, right? And we're going to see the same pattern in the other context as well, in the context of democracy, right? We want to facilitate positive pressure from the people on the government in the form of voting and polling and all the proper and healthy democratic processes, right? Without any negative misuse of that information in the form of too much propaganda or whatever, or some of the classical negative flows of information in a democratic context, right? In terms of capitalism, right, we want to facilitate positive flows of information, such as very accurate pricing, right? Because that's actually a really good thing because it indicates the quality of goods and services, right? We want to facilitate accurate ratings of products and services, so that individuals who are kind of small, not very powerful actors collectively can pressure very powerful corporations into building great products and doing great things for them, right? And that the any bad products would go fall down by the wayside, and good products would come up, and corporations would be incentivized to create the most possible welfare for individuals, right? So already we're starting to see this pattern, right, amongst these three big institutions, which I would say are kind of like the three great areas where we can innovate in information flow. that there's all about promoting positive uses of information while mitigating negative uses of information, right? So, but there's sort of different natures and different types of positive and negative uses in these three different categories. And this is where I suspect some of this narrative is going to start sounding really familiar, right? The notion that privacy is about mitigating negative uses of information is widely known. Like I think this is probably what if the average person sat down for a long time and thought, what is privacy about? That's probably what the answer they would come to. However, I think that there's sometimes a little bit too much focus in the privacy community on mitigating negative uses, because just mitigating negative uses often has trouble in the competitive dynamics with like when people say, why should I care about privacy, right? People will say, oh, well, because aren't you worried that people are going to harm you using your information? And the truth is that like most people don't necessarily notice any potential harms from information very often, unless they get like their identity stolen or something like this, right? But when we have the opportunity to focus instead on all of the positive things that could happen as a result of privacy tech happening, like all the ways that we could actually get more out of information if we were able to better govern it, right? Then all of a sudden, and we'll see this in the patterns in these three elements, we'll start to see more information flow in the really positive ways that we want to go, right? And this has really, really incredible competitive dynamics. Okay, so we're talking a lot. Let's do a checkpoint again. So chapter 1, privacy is all about information flow. Chapter 2 is trying to answer the question, if privacy is about information flow, what information flow should we care about? We break down the problem by first saying that there are two groups of problems that we care about. One is making it so we understand nature more. The other one is, of all the value that we get to receive from nature, how can we better distribute it amongst individuals, right? And sort of information flows part to play in these three great institutions is by facilitating like positive uses of information. So in the case of science, more discovery, right? In the case of democracy, better representation. In the case of capitalism, more accurate pricing about what products are good and bad. And in the while mitigating any negative uses of information. So in the context of science, it's the use of science data to exploit participants, right? In the context of capitalism, right? Negative use of information could be overly aggressive or accurate marketing, or marketing that would like that makes people buy products that aren't actually the best, right? Or that corrupts sort of feedback systems, such as like review systems and these kinds of things. Or in the context of democracy, any negative uses of information that are used in the form of like propaganda or intimidation or anything like this. Like I'm speaking this very kind of the textbook negative uses of information in democratic flows, and now we're gonna try to look at some themes. So like if we can generally say, okay, well, of course, like these are great, we want positive information or positive flows without negative flows, but like how are we going to accomplish that, right? Okay, and like what does that even mean? And this might be a point, or we're about to go into chapter 3, which is sort of like how do we accomplish these flows of information? But I think that we actually need a little bit of an intermediate chapter. Like it's tempting right here to go straight from, privacy is about information flows. The information flows that we have in these three different institutions is all about facilitating the good ones without the bad ones, right? So how do we do it? But I think there's actually an intermediate chapter here, because there are broad strategies that we're going to try to employ before we actually get into the technology, right? And this is the part that I think is most missing in people's sort of roadmaps and product strategies for how to make privacy actually happen. Because basically the main strategy in privacy technology right now is one of two things. Have users encrypt their own data so that they can sort of force some kind of information flow because cryptography is really hard and robust. Or 2, regulate, right? And like write some law that just makes it happen, right? And the problem with these two core strategies, right, is that they're kind of like they're sort of hard power or sharp power. I think sharp power is like this kind of new term. It's really interesting. That ends up butting against other really powerful forces in society, like capitalism or democracy or scientific innovation, and that creates inherent conflict. And it's like we as the privacy community are choosing the hard path, right? Instead of getting capitalism and democracy and the scientific institution to work for us, we're trying to kind of force ourselves in there and say like, all right, we're just going to encrypt it, and like that's just going to be the way it is, right? When I think that there's actually a much more efficient strategy that we can take, and that's all about not just focusing on mitigating negative harms, but actually showing that when we can cover the downside, when we can prevent the negative harms, we actually get way more positive utility out of it. Let me show you an example, and again, Nick Rose is going to jump more into this in a second. In the scientific innovation realm, okay? In the scientific innovation realm, you might say, why does privacy matter, right? Hospitals have data, they do research, it's great. I would argue that the big data revolution has not come to science yet. It's come to parts of it, right? I think machine learning, image classification, it saw a huge increase in the data set size as a result of GPUs coming to fruition, right? And this led to an explosion in AI machine learning research, right? Thanks NVIDIA, right? And I think it's like there's so many articles and stuff written on big data that everyone seems to think that it's already happened. But if you try to go do real science somewhere, right? If you instead of just trying to train a machine learning classifier that does a task, right? If you try to go and say like, I want to understand why people get depressed, right? Crickets. Where are you going to get data for that, right? Where? It's just doesn't exist, right? And you might go and you'll find like, I don't know, some study online and it gets like 300 people that all fill out a survey, and it's like, are you kidding me? Like you for hand digit recognition, we can get 60,000 entries for free online. But for the problems that really matter, right? The problems that are valuable or are private, the data doesn't exist. Well, that's not true. It does exist, but it's in silos, okay? And again, this is all under the theme of we as a privacy community should be focusing on the value that can be created by covering the downside, right? Now, let me show you what I mean. And again, Nick will unpack this more in a second, but like in the scientific community, right? There's loads of apps and institutions, everyone from your bank to the credit card transactions that you're buying to the text messages that you send each other. Like data about, say, depression exists, but we can't study it, right? And why can't we study it? The reason that we can't study it is because it can be misused in really, really horrible ways. And if it was misused, like tremendously bad things would happen, right? And so as a result, we don't get to study it by and large, right? Unless you are a specialist dedicating a portion of your life just to studying depression, right? And you go to a depression lab at a top university and you're like getting funding to survey hundreds or thousands of people or whatever, like unless you're that person, you don't get to do it, right? And that to me says the big data revolution has not happened. If leading studies are still only have 300 people participating in them and fill out a hand survey, meanwhile, our data, our lives are being digitally recorded all the time, right? The big data revolution hasn't happened, right? And this is a classic example where if privacy technology existed, if we solved the technical problems of privacy, right? Such that it just wasn't a problem anymore, and we'll talk about that in a second, virtually overnight, we would get 1,000x increase in the amount of data that is available on all the world's most important issues, right? Because the world's most important issues are the world's most personal issues. Like it's problems about people that we want to actually work on, right? But if we just go around saying privacy, 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 high dollar data, high dollar data, high dollar data, one, like we're intentionally pitting ourselves against innovation. And two, we're missing the bigger picture that like if privacy gets solved, we get loads more data for innovation, right? I mean, you want to talk about whether a privacy startup could outcompete a non-privacy startup. If you've got 100x more data, you will outcompete the non-privacy startup, bar none, right? Go to Silicon Valley. Like startups in data science live and die by whether or not they have access to the data. And if you can solve privacy, you will have more data than anyone else. You won't have the individual records, but you'll have the ability to create products and services based on it. Okay. And this is the big strategy, right? When we as a privacy community think about what we want to build, we need to focus on the offensive. We need to focus on the affirmative, on the things that you will now be able to do because privacy tech exists, and not just running around trying to scare people into all the bad things that might be happening to them as a result of privacy invasion, right? This is how we get capitalistic and democratic forces working in our favor, right? That are like pushing for privacy tech to happen as fast as humanly possible because there's so much value to be unlocked, right? As opposed to right now, we're just jutting against existing institutions and existing systems, right? And most importantly, and like this is the theme of the lens, right? Is that privacy technology, by getting rid of, by mitigating these negative use cases and creating these positive use cases, just change the narrative, right? So that's strategy number one. Okay, so just to checkpoint one more time, where are we in this talk, right? So first we said, what is privacy? Privacy is about information flow. Then we said, okay, what information flows matter? We answered the question, what information flows matter, by first saying, hey, the world's problems can be divided into two things. One is about innovating more, right? More prosperity, better understanding of nature, thus, better quality of life for humans on average. And the other group of problems is about how do we distribute resources amongst people fairly, given that we have a certain number of resources, right? Okay. Now, after that, we said, okay, then it's about flowing information flows towards these aims, right? And we picked three big institutions. We picked the institution of science, we picked the institution of democracy, and we picked the institution of capitalism, right? And we want to facilitate the positive information flows towards each of these aims while mitigating the negative information flows towards each of these aims. And that is, and then we said, okay, given that we want to do the positive information flows without having the negative information flows, then okay, great. We noted that. What are the strategies that we should think about when trying to facilitate these flows, right? We can't just build the software and expect people to use it, right? The place to start is to have high-level strategies. And the first high-level strategy is focus on the positive. Focus on the revenue to be earned if we can solve privacy, right? Focus on the availability of data for study, for use, for all manner of innovation, right? If we can solve for the downside, right? If we can prevent misuse, right? And that's the first strategy. The second strategy, right, is to focus on facilitating information flows that changes incentives, okay? And this is really just about championing truth, okay? Because like truth generally leads to quite good incentives. And in the case of science, the incentives are, if privacy technology is not solved, right, and I have some really valuable data, if I give that data to someone else, every person that I sell that data to instantly becomes a competitor for uses of that information, right? And so that creates perverse incentives, right? Broken incentives, to the extent that it either means that it's going to be a race to the bottom, where I'm going to sell it as fast as possible so that I can sell it to everyone before they can go and sell and eat up the market before I get there, which that kind of data markets are covered in privacy literature a lot. Or it creates an incentive to never ever show this data to anyone ever, right? To totally hide it away because it's mine and because I'm going to extract all the value from it without allowing anyone else to see it, right? And this is the one that really kills innovation, right? And not just that incentive, but also the incentives we create a bunch of legal liability and risk for sharing particularly personal or valuable data. And notice, this incentive about hiding information has nothing to do with it being private data and everything to do with it being valuable data, right? It's not just like privacy is not just about the negative personal harms. It's also about the fact that we if it's really good for innovation, they have even more incentive to hide it, right? Because it can be copied because anyone they give it to could become a competitor for use of that information, right? And so if we solve privacy, if we make it possible to answer questions using data you can't see, we can fix this incentive problem such that all data can become available for scientific study, right? Without any of these broken incentives, right? That cause people to want to either data hoard or spread it as quickly as possible. Okay, so this is gonna be our two strategies, right? Our two strategies are focus on the positive, focus on the innovation that can happen as a result of us solving privacy, and two, focus on incentives, right? Focus on how we can facilitate information flow that creates the incentives that we want to have happen. And now finally, given that we have these two high-level strategies, which are going to be addressed in the two talks that follow mine, I want to finish by just breaking down privacy into a single technical problem that has four main parts, okay? Earlier, I talked about the technical problem of facilitating positive, beneficial information flows without accidentally activating negative information flows, right? And this might sound easy to the extent like, oh, just send emails to the people you want to send emails to, and don't send it to the people you don't want to, right? But the problem comes down to one core technical problem that causes us to sometimes not be able to disentangle positive uses from negative uses, right? This technical problem, which I think is a good summary of where all of our technical tools ultimately seek to plug in, is a problem that I like to call the knowledge consent problem. And it basically says, if I want to collaborate with another person, right, which requires me to share information with them, I cannot prevent them from later using that information against me, right? Matter of fact, I cannot prevent them from using that information for whatever they want, right? Once I've conveyed it to them, right? It's this notion that information is infinitely copyable, right? And this technical problem flies in the face of the very definition of privacy that we started with, which is the ability to facilitate specific information flows and not other information flows. And so when we think about privacy technology as trying to create these specific information flows we have, the chief technical problem, the chief puzzle of privacy is this problem that I cannot collaborate over information with another person without giving them the ability to use that information for whatever use they want to in the future. Privacy technology, and this problem has existed since the beginning of human communication, right? It's an encoding problem. It's the fact that we encode things in plain text, and everything that's going over this video, you will now have the technical ability to copy or reproduce or do whatever you want, and I have no technical ability to stop you from doing that, right? But for the first time ever, since the dawn of human communication, privacy enhanced technology is going to change that. Right? It's going to make it possible for two people to collaborate over information while limiting what the other party can do with their information that was involved in the collaboration. And that sounds kind of technical, right? But let me break it down with a specific example. So like imagine if you were going to the doctor, right? Normally you go to the doctor and you give them your medical history, your medical records, your symptoms, whatever, and they give you, they take your data, they process it, they think about it, they run tests on it, whatever, and they give you back a diagnosis, right? And then you know what's wrong with yourself, and you go take some pills, and hopefully you get better. And you might think, is it actually possible for us to collaborate without the doctor being able to do whatever they want, in their head, technically, like with the information that they learn, right? Or put another way, is it possible for me to receive a diagnosis from the doctor without them ever actually learning anything about me? And before privacy enhanced technologies, the answer was clear, it's impossible. But with a combination of remote execution, encrypted computation, and differential privacy, this is possible now, right? It's possible for a doctor to encode their information in a software program, like using something like machine learning, right? for you to encrypt your information and for them to apply their intelligence to your information, right, to give you a medical diagnosis, right, without them ever learning anything specific about you. And it's this combination of these three technologies, right, like encrypted computation, differential privacy, and remote execution, that makes this possible. So now giving you a specific example, let me break it down into what I think are the kind of the four main sub-problems that we should tackle as a community to ultimately allow us to create the positive information flows we want to have without the negative information flows. And those four things are input privacy, which is output privacy, input verification, and output verification, okay? Input privacy, for those of you who aren't already familiar, is the ability for two people to compute a function while both people keep their input data secret. Okay, this is like input privacy is literally what I just described with the doctor and the patient, right? So it's the ability for the doctor to bring their knowledge of medicine, all this kind of stuff, right? And the patient to bring their medical history and this kind of stuff, and compute a function, the output of which is, what's my diagnosis, right? What disease do I have, and what should I do about it? Without either of them revealing their inputs, right? That's what's called input privacy. It's about hiding the inputs during the computation, right? And so the technology that makes it possible for a doctor and a patient to produce a diagnosis, while the doctor keeps their IP and proprietary everything secret, the patient keeps their medical record secret, is called input privacy, right? And generally speaking, it's the field of encrypted computation. So secure multi-party computation, homomorphic encryption, functional encryption, secure hardware, like these kinds of topics, secure computation. It's got a host of these different words, but they're all referring to fundamentally the same thing, right? Second one is output privacy. Output privacy it sort of works really well with input privacy. It's all about saying, okay, given that you did input privacy, good for you, right? How do you make it so that you can't use the output to reverse engineer the input, right? And the textbook example here is in statistics, right? So when you're doing a big statistical survey, right, and you publish your results, and it says, smoking causes cancer, with a 30% greater chance or whatever. And you publish some big table, it's got a bunch of fancy numbers, right? And the question is, can someone take your big fancy table with all your analysis and reverse engineer Andrew Trask has cancer, right? And because if you could reverse engineer that would be a privacy invasion, right? But it's not the same group of problems as input privacy, right? You're not saying like it's not about two people's inputs hiding their inputs. It's about, can the output reverse engineer the input? The output being the statistical results or the medical diagnosis or whatever, right? And there's a whole field. I think the main one being differential privacy, but there are other techniques as well that try to facilitate this output privacy. Okay. Now, input and output verification sort of go hand in hand with input and output privacy. And input verification is all about this technical problem that basically says, okay, given that we are doing input privacy, right? The doctor is bringing all of their medical knowledge, and the patient is bringing their records. Now we don't have the ability to actually see if the other guy has good data, right? Is the doctor actually qualified, right? Did they pass all of their medical exams? Are they up to date on all of their certifications, right? And on the patient side, is the patient being honest? Are they actually saying all the symptoms they have? Are they lying about some of their symptoms, right? And because we're hiding this information from each other, it becomes much more difficult for us to just know whether it seems like a reasonable input, right? And so what input verification is all about is about facilitating the verification of the input data that you cannot see, right? And there's two main groups here that are worth looking into. One is just cryptographic signatures, which many of you might be familiar with, and the other one is sort of zero knowledge proofs and ZK snarks, which are very useful for kind of this foreign verification of certain properties of data information in a particular information flow, right? And the last one is output verification, and this one says, okay, so again, the general context is like the doctor and the patient, right? So we're facilitating a very specific information flow in the spirit of Dr. Helen Nissenbaum's philosophy, right? And the information flow is that piece of information, comes from the doctor and from the patient, and it computes a fancy a fancy algorithm, and that produces, a key finding, which is the result and output that is, whether the patient is sick, right? So in this information flow, we protected our two inputs using input privacy. We kept us from being able to reverse engineer the inputs from the output using output privacy. We verified, the doctor is able to verify that the patient was actually bringing in medical records using input verification, and the patient was able to verify that the doctor is indeed still qualified, is like passed all the exams, all this kind of stuff, right? Without them having to actually see all the doctor's information. And now we get to the end, we produce this thing, and we're going to ask the question, okay, so this is the diagnosis, right? This diagnosis was created from this whole computation. I wasn't able to see any of the inputs, and I can't really reverse engineer the inputs from the outputs. I wasn't able to see the computation either because that was encrypted too. How do I know that this actually was encrypted, was created correctly? Even though the doctor's qualified, how do I know that this result is fair, right? Or is it, it's not biased based on some attribute about me, my gender or my race or whatever? How do I know that it's accurate, right? Or that the doctor actually followed medical procedure in the creation of this output, right? How do I verify that the computation that I couldn't see because it involved lots of private attributes actually did the things that it was supposed to do, right? And this is the field of output verification, or the subproblem of output verification. And there's a lot of different subtopics that sort of map onto this. So verified computation is kind of the most obvious one. Also, tools like Secure MPC often have something called active security that does this. But then there's also the broader fields of machine learning of like fairness, that's just trying to actually study machine learning models and make sure that they can verify certain properties and these kinds of things, right? And so when we think about trying to facilitate specific information flows, I hope that you'll take whatever work that you're working in and sort of map it into one of these four technical pieces, right? Which is either input privacy, output privacy, input verification, or output verification, right? Apply it in a more general context that is focusing on the positive, focusing on the things that we can create, right? Not just the things that we can prevent, because this is how we actually activate the incentives we want in life. And second, that you'll focus on the incentives, right? Focus on changing the incentives by facilitating specific kinds of information flow, right? Like you want to have better products and services, facilitate better incentives or facilitate better information flow about what products and services are good and bad, and you will change the incentives that companies have to create better products and services, right? I mean, this is a standard, if there are more reviews for products and services, there will be better products and services because consumers will be able to make better decisions, right? Yes, so this has been kind of the broad view, sort of introductory piece of how we should be thinking about privacy and privacy technology. And in the next two segments with Ronnie Falcon and Nick Rose, they're going to unpack specifically the science institution, right? And like our specific roadmap for what we think that we should build to unlock sort of the next great wave of innovation within science with privacy technology. And then Ronnie is going to look into both the sort of the institution of democracy and democratic flow and representation, as well as capitalism, and really apply these base principles within these different institutions to accomplish a fair and prosperous world. So thank you very, very much for your time and for listening, and I hope you enjoy the next segments.